Welcome to Harnessing the Power of Civil 3D for Quantities Computation. My name is John Blomquist. I'm a civil engineer at KL Engineering. You can see me there in my full COVID gear. I've been with KL Engineering for over 24 years. I started in Madison. I'm currently located in the Menominee, Wisconsin office. A little bit of history, design packages I've worked in. I started out originally in Eagle Point and transitioned to Casey and now Civil 3D. And I've done a bit of work in inroads as well. There I am, free from my COVID gear. So what am I going to talk about today? Well, I'm going to be going through several ways that you can compute quantities using modules located in Civil 3D. I'm going to go through PItem files, the QTO or Quantity Takeoff Manager, formulas utilized in the QTO Manager, code set styles used to apply corridors to pull out quantities computations, material manager to compute materials out of your cross sections, and volumes tables. So a PItem file is kind of the bones of the whole operation, and it is just simply a CSV format text file, which you can edit in Excel. It contains 3 columns, an item code, an item description, and a unit. That's it. For example, the excavation, this is what one line would be like for excavation common item. Here's the bid item number, the item description, and then the unit. Wisconsin DOT has provided these PItem files for the spec years of 2016 through 2020, and they are completely customizable to meet your needs. So here's the QTO Manager. It can be found under the Analyze tab by clicking on this little icon over here that looks like a dump truck. By clicking on that, it opens up the QTO Manager, and this is showing the typical view that it's opened with the DOT spec set. As I mentioned, it is customizable for each project, so you can pick and choose which items you want to use in the QTO Manager. This is also the QTO Manager. I've kind of expanded it. This is a customized PItem list showing a formula for tack coat. So tack coat is a gallon bid item. There is no way to quantify a gallon of something. It's a volume type measurement, and there's no way for Civil 3D to do that. So you have to type in a formula to let it know how to compute that. So whatever item you select, it takes the area of that object, divides it by 9, because it has to convert all item areas unless if you select an item area under this item with square feet, it would compute it square feet. If you compute it under this item, it would compute it as square yards. But for gallons, it doesn't know which to use, so it defaults to square feet. So you have to convert it to square yards, and then 0.06 gallons per square yards gets you the gallons. So there's used to compute quantities for those types of items. You can use area and length. There is also a each, which is like a count. And there's also a formula for depth, but don't be fooled by that. That is actually just, it'll pull a depth out of a culvert pipe, but it is not pulling anything from anywhere else. So you need formulas for computing things such as pounds, tons, gallons, and cubic yards. So, as I mentioned, these are the variables available. You can use areas in square feet or square yard, and actually also acres. Length for linear feet or mile, if a different unit is required. Like yards, you could do that as well. You could just item length divided by 3. So drawing objects, any object that can be selected can be itemized. So essentially, you can pick a polyline, a point, hatches, literally anything that you can think of in Civil 3D that is quantifiable by an area or a length or an each, you can use as a quantifier for a bid item. So example, hatching for areas. You can flood or select an object. Something you want to be careful of when you're using hatches is confirm the integrity of the hatch. By that I mean you got to make sure that the hatch has an area associated with it. So select the hatch and look at the properties and make sure that there is an area. If not, it will quantify as a 0 area no matter how large it is. Regarding polylines, make sure that you're consistently use either the hatch or the polylines. I've seen cases where areas may be double counted initially because both the polyline of the outlier hatched area was used as well. We're going to also go through computing of volumes from both the corridor and from cross sections. It's similar to the process used in earthwork. It actually uses the same material list, and we just modify it to add in additional items such as base course, break or run, that type of thing. So the whole process is started by creating a PItem file or by using the DOT standard. You gotta load that into your QTO Manager, develop formulas for the items that you need formulas for, and then you're going to assign bid items to objects in the file. So let's get to showing you examples. Here we are. I've opened up the file that is similar. Well, not similar, it is essentially a PAVT file that shows edges of pavements. It's got some curb and gutter here, a little sidewalk, just a short little section with a little varying width to show how it computes quantities. And first thing I'm going to do is I'm going to create a group layer so that I have all of my bid items layers in one location to easily find. There, do a HMA shoulder layer, to do a concrete sidewalk, to do a curb and gutter layer. Make sure that these are a little discernible from the existing ones. I'm going to create some different colors here. Concrete sidewalk. This is concrete pavement. I should just. So I got that as my active layer. Select my MQ as my filter. So I go to my home tab. I'm going to create a hatch under concrete pavement. Just flood the area. Concrete sidewalk flood. HMA shoulder flood. Now you can either do it individually or combined hatches I have here. We're going to do a linear foot, convert that into our curb and gutter, convert. There. Now what I'm going to want to do next is I have my areas here. I'm going to confirm the areas to make sure that they are indeed good to go. So there is my area. It has an area associated with it. There's that hatch, has an area. We're good. And we also have an area with that. So we are good to go. Just double check here too as well. Make sure. Yeah, we get a length. Okay. So I'm going to open up the QTO Manager. I'm going to turn off categorizations because I have created a PItem file of example items. So this is something that I've done ahead of time. All that is a spreadsheet with 3 columns as we discussed. And here's the bid items associated with that, and here's the units. So I threw a station in there to give you an example of what I'm talking about as far as that length computation. So I'm going to go like this. I'm going to length. And I'm going to assign the pay item to this shoulder here. It should have a length of 994. Do a takeoff of it just to show you there. Since it shows station, even though I did length, it's 994.01, which is 100 times the length. So in order to get that to be what we are, got to do 10,000 divided by to get that properly. So if I go to this length and I do a takeoff, you'll see that it converts to 994. So it does that automatic conversion through there. All right, we're going to do assign pay item. Assign that to the object. Do attack coat, assign that to that. Asphaltic surface, assign that to the same area. There we have a formula. I have my area. I have to divide it by 9 again to get to square yards. I have a 4-inch thick asphalt shoulder. If you're going to have multiple thicknesses, you're actually going to want to create multiple bid item numbers for that. So you'll have like an asphaltic surface 4-inch, asphaltic surface 5-inch, for example. You're going to want to do that. So you're pulling out your formulas for different thicknesses. And okay, I think we're good. Oh, concrete sidewalk, I have to do that one too. There, I have all my items selected. I'm going to go ahead and run a summary report, and this will give me all the summary of the total quantities. Another report we can do is a detailed report, and we can have it associated or report the stations relative to the main line. Do a compute on that. There are different reports here. Here's a detailed area report. So it shows the areas and centroid stations. Detour linear gives you a start and end station, start and end offsets along with the lengths and volumes, but we don't have any volumes, and we also did not have any each items. I take that back. We do have each items, and those get converted into the any item that is not a length or an each is converted into a detailed count item. And lists the formula there as well. So that is the simplest example that I have of like a square foot surface and linear foot items. This can be applied to any type of object. You can have insert cells and then do an each item, for example. It's really limitless in its applications. Next, I'll pull into a little more detailed example of a little more complexity using corridors for the similar process. What I've got here is a corridor template file. Essentially, it's just got a couple of files or alignments loaded in to target for the edges of the corridor and a reference of a pavement file behind it. I'm going to unload that just to give you an idea of what we're talking about. In order to save time, I've also created a couple of assemblies to run along this corridor. One is a rural on both sides, and the other one has a sidewalk section along the side, as was represented in the pavement file. So the very first step I'm going to do is I'm going to kind of show you, this is what comes out of the DOT standard templates, standard everything. Nothing was modified except for the pavement depths and whatnot. You can see I created a code set style so that you could see the codes that are associated with these links. So this link here would be pave 1, this one is datum, this is top and label PCT. So it's not a lot of extra information associated with it. This one here is sidewalk. So there's really no association with what type of pavement we're talking about. So then I took that, and then we go into a little more detail, added in some more detail on some of those corridors so that we can then quantify it out of the corridor. We add some information about seed types, the shoulders, and you can see the sectional area of the different materials that are being used. used. There's a base 1, which represents the 1 1/4 inch, and then the base here, which represents a 3/4. Shoulder pave represents the asphaltic surface on this particular project, and the concrete. So I'm going to show you how to get from here to here, just by going through a couple of examples. So we're going to select the lanes and select the similar assemblies, and that we get all of those all at once. And we got the different links here. The top link that we saw that was top in PCT, we're going to add concrete onto that to give that a little bit more functionality. We're also going to change the name of that pave 1 to concrete, because a little more description on there, because there's other pave 1s. For example, the sidewalk here was pave 1. The bases we're going to end up leaving as it is. The shoulder assemblies, we're going to select those. We're going to add a little more information to those as well. This top here, this is going to be top SHLD. Actually, let's just leave the top shoulder off of that one, top HMA. Everything else as it is. This top slope is the top slope on the base, so I'm going to add information on that because we're going to want to put some seed on there. I'm going to add the 30 to that. These other ones as well. Okay, now daylight sub-assemblies, select all those. Again, they don't really have much information. I'm going to want top, I'm going to want datum, because I'm going to create my datum. That. So we're going to add in label slope. As well. So we have that. Sidewalk here. Create the sidewalk pavement instead of pave 1, we'll call it sidewalk. We're actually just going to put 3/4 inch base underneath that, so we're not going to need a different identifier there. Side terrace top. We're going to want to add some seed onto that as well. Terrace. Top of the sidewalk is fine, and outside terrace top. There. Last one left is the curb and gutter. Terrace link. Gutter link. Top. There we go. It's the datum. 30 seed. There. I believe our assemblies are kind of all coded to what we want to do. Then we're going to go into these multi-purpose styles and do a code set style. We're going to do a new one. We're going to import codes from these assemblies that we had created. So I'm going to go through and just do an example one before I kind of jump through everything. You have to go through each of your surface types and do this to each one. So I don't see anything for concrete here, and I want something specific for my link style for concrete. So I'm going to create one just for concrete. And we're going to display, and we're going to create a P section. And we'll just throw this under the lane cross section. Everything is going to be by layer. Here's some pounding. I apologize. Our office is getting renovated. I'm hoping it's not too distracting. I've kind of gotten used to it. So everything is by layer. Again, I'm just going to do one example. This is actually going to be completed for each of those surface types to get it to look the way that you want it to look and to quantify the way you want it to quantify. Well, actually, the quantifying is independent of this style, but it does help to visualize what you're dealing with. A render material, I'm going to use concrete. Material area fill. I see no concrete there either, so I'm going to do a new one again. So I'm going to use the same thing that I had used for the link, but in this case it is the actual material fill, which was the shape. So even though I'm under the link, it is also going to fill that that between the links in the plan view is what this material fill will take care of. So as soon as I'm done here, okay, and now here I can also associate a pay item with that material fill area. So there we go. We have concrete now and everything associated with that. So now I'm going to actually create the corridor using that new style that I created. Split the region because we're going to have two different assemblies. Assembly 1, assembly 2. Targets. Just to the right is right EP. To the left is left EP. That for the second region here as well. Right EP. Left EP. Okay. Okay, we're going to rebuild that. It's going to default to the DOT standard style setting, so we really don't see any of the things that took effect when I was modifying that assembly style. In order to have that take effect, we actually have to do that here under the codes. You apply the new code style set. Lo and behold, there you can see the shading that was completed using the concrete surface type. The corridor properties for the concrete pavement, but we want to add a few more to kind of flesh things out a little bit here. So we're going to edit the code style set. Let's get something a little more descriptive than new code set style. How about MQ? Because we're going to be using this for quantities. So we'll go under the links here. We have the concrete associated. Let's do the curb as well, because that is also concrete. Let's also do the sidewalk. Okay. And let's just go ahead and associate that with the rendering as well. Concrete curb, sidewalk. Okay, so then we're going to want to apply concrete. Material is concrete. Let's go ahead and apply that. There. Now, as you can see, those three items are shaded. Okay, now let's go into the feature lines. As you can see, they all default to just one particular standard style. I'd like to clean that up a little bit and maybe even do some quantities computations with that. So let's go under that code set style again. And this time we're going to go under the points. Instead of having all of this style as standard, let's turn them off. This initial standard style here, it refers to those that happen in the cross-section view or in the corridor section editor. The label style refers to like the text labeling. We're not going to do any of that for our quantities. And the feature line is how it shows up here in the plan view. So I'm going to reset all of those to none or no display. And then I'm going to go through and pick some individual ones that I want to show up. So let's do a back of curb. Let's see if we can get it to mimic what it shows up in the pavement file. So we'll do the lane edge on the crown. The daylight will be the slope intercept. A ditch, sure, let's do the ditch too. Let's see where we have ditches. Flow lines, edge of paved EPS is edge of paved shoulder. Edge of shoulder is the gravel shoulder, so let's take care of that as well. And edge of traveled way is the edge of the normal pavement. Face of curb is also the flow line, but we'll do this in the flow line. We'll use the ditch flow line since there isn't one specific to a curb flow line. All right, the sidewalk is the path. Path for this one as well. So that should take care of that. So let's go ahead and apply that. Okay, so we're going to have to go into the corridors. In order to reset it, we need to first go out of that and apply another code set style, then go back in, reapply it. By doing that, it automatically resets the codes here. So as you can see, there's the center line, there we got the edge of the shoulder, we got the sidewalk, we got even the ditch flow line right there. So as you can see, we can also associate PItems with these feature lines. So let's do that. Now the flow line of the gutter is something that we would like to have paid. That is a measured location for the payment of the curb and gutter item. So we'll do that. And let's also do edge of traveled way as the slope intercept or the slope staking. If we were to do the actual daylight point, it would measure the length of this chain, and that's not what we're looking for here. So that's why I selected the edge of travel way for that particular item. So is there anything else that we want? I think we're going to be okay for now. So let's rerun that corridor just to be safe and do another takeoff. There, now we have curb and gutter and construction staking slope stakes. So ultimately we can get a bunch more of the quantities out of here by associating, by changing the code set style, which I have already done under this generic corridor here. I'm going to do a takeoff on this table here and we'll report. I did a detailed report. I wanted to do a summary. There we go. Summary. There you can see the items, quantity we have. Got concrete sidewalk, seed mixture, 30. This construction staking slope stakes. This is how I found the item was wrong, is because I had more than I thought I did, because I did associate with the daylight. So it pays to double check your quantities and how you're applying them. The concrete pavement. And the next thing we'll be getting into is what we're seeing up here is the volume quantities. In order to complete volume quantities, we have to, again, go into the code set style. Let's edit that again. And this time we're going to go into the shape. And as you can see, here are all the shapes that we had associated with that corridor. We have the base, which we do not have. Create a new one. This is how it's going to show up on your cross sections. So just wanting something to be able to check your quantities. You can do that visually on these. By layer. Actually, we can go just, I forgot, we should go just down into the section here because we're actually not going to worry about viewing this in the plan view. Layer, by layer. Let's do a predefined, sure, ANC 31, scale of 1. Okay, let's see what that looks like. Base 1. Copy this one. Go to the section. Let's duplicate this layer, except for with base 1. And we'll change a color to differentiate it between the others. Let's just throw a blue in there. Go. Sure, we can use that same thing, but let's just throw a negative angle in there, and let's do a scale of 2 so that it looks a little different. That's so that the name is consistent with what I'm renaming here. So we already had the concrete, so let's go ahead and apply that. Concrete again, because they're all concrete. Shoulder paved, we're going to want to do a new one for that. Let's do HMA. Let's see what we got here. Let's do it as pavement. By layer. By layer. Solid is good for this one. I keep forgetting to go to the section because that's really the only one that we're interested in here. And we'll keep that as solid. So now when I go into the corridor section editor, and if we set that options as EMQ is our style, you will now see the areas. Oh, and as applying this, we can see that we got a little discrepancy. That's one of the reasons that we do that, is to make sure that we're consistently calling out the correct things. So it looks like we have our base in base 1 mislabeled on the shoulder fragments. So make that correction here. Looks like we missed it. All right, so here is the shoulder paved. Here's the base, and then this one we also want as base. This is base 1. I think problem here. Let's give it a try. Sure enough, that took care of what we needed. I wanted this to be 3/4 inch base underneath the shoulder, and all this underneath here to be the 1.25 inch, which I have represented as base 1. And it looks here right also. This is what I also wanted, is the 3/4 inch base. So we're going to go ahead and use that to compute our quantities. So we just completed creating the concrete surface. I want to drop back into my corridor, generic corridor file, to show you what it could look like if you spent a little time creating some of the surfaces a little bit more forethought. Here I have, like, the gray is the concrete, the red is the sidewalk, and the green is the grass. Now, we had also applied some rendering under one of the surface, or the code set styles. And if you're wondering where that is, let me just go back and look here. See the render material that we used for the links. If you're wondering where that came from, you can go into your view, and there is a realistic view that is applicable, and that applies those surfaces that you selected to the corridor, and does somewhat of a more realistic type rendering. So go into 3 dimensions here, and you can see the concrete, the different types of concrete, the different types of grass, the gravel shoulder, and if you like, you could even bring in the existing surface behind it. Pull that back up again. I inadvertently exited out of that. So here's the render material that you're allowed to select. So I'm going to just do a thick grass. Now, if you wanted this to look actually as you were finished, you would have to compile these 2 surfaces together. The way it is now, it'll look fine within the surfaces of the corridor in areas where we're filled, because it'll go over the top of the existing ground. In the other areas, the surface will overwrite over the top, as you can kind of see there. In the cut, the surface overrides, but otherwise you can kind of see what we have here in the fill and rendering. So I'll exit out of that and get back into our corridor file, and we'll go through our computing of the volumes. We're getting a little bit glitchy, so I exited out of the program and got back in. Before I started back up recording, I made a couple of corrections. I had to correct the end limits of this to match up with what the pavement file was. And I also created a datum surface that associated with the corridor so that we could create a materials list from it. I also inserted scan lines. The scan lines is what's used to compute the actual volume quantities. It does end area computations between these. So you want to insert the scan lines at locations where there's a distinct change in the section, and make sure you incorporate it. Like at this location here, we go from the urban section to the rural section. During a normal design, we would clear this up and make everything look all nice and clean, and probably have a couple more scan lines. But just for our purposes here, I inserted a scan line on the rural side and one on the urban side, just to show you what I'm talking about here. Let's create some section views. So we're going to have some section views. We're going to have one. This one here should be a urban section. And the next one should be a rural section. Sure enough, that they are. You can see the datum here. As I was mentioning, we'd normally be cleaning that up if we're doing the final design, but just for the purposes of this example, we're not going to really worry about it. All right, so now that we have our sections, we can compute, or our scan lines actually. We have to have scan lines before we can do a materials list. So we're going to go under the Analyze, under this Volumes type tab here. We're going to compute the materials, the same as we would for earthwork. And essentially the same start is to what we do for the earthwork. We select the existing and the datum surfaces, the average end area, click OK. The difference is we're adding an additional step. We're also going to compute materials again, click OK. And then we're going to add a new material, and we're going to actually compute base utilizing those sections. So under the quantity type here, in order to utilize a corridor surface, you actually have to use the structure's quantity type. So we have a corridor shape. There's our base that we had defined before in the corridor. So I'm going to add that, and let's have that drawn as base. Add another material here. base 1. This is a structure, corridor shape, base 1. And those are really the two primary end area computations we're going to use for volume, but we actually also can use some of these as a check. So I'm going to actually put in the concrete here. Go to the structures again. We'll do concrete. And then I'm going to create surface end area from that as well. There's computing. So now what we can do is we can create a material volume table from the information that we created in the materials list. So I'm going to select the base, and I'm just going to leave the rest here as a default. If we wanted to do a snapshot, we could actually keep this as a static. Otherwise, it will actually modify the quantities based on the corridor changes. So as you can see, here's your base volume. We had 290.76. And just to show you an example of what I'm talking about, I'm going to go ahead and I'm going to change the assembly width here to the shoulder. Let's go to a 5-foot gravel shoulder. And rebuild. You notice the areas changed and updated our volumes automatically once that was rebuilt. So that's quite handy if you're going from preliminary to final design, to have that be able to have the capacity to update. I'm going to just to where we were, rebuild again, and the table will update. All right, so I'm going to go back into our generic corridor file here where I had already done a lot of this other work, and I'm going to kind of show you some of the tables that I exported out and kind of some of the usefulness of it. I had created the 3/4 inch base, I'd created 1 1/4 inch, and I computed the tonnage of the material necessary for that based on these volumes. The concrete volume table, this is more of a check. Here we have the 768.4, and then this is the volume. To convert the volume to square yards, we're going to divide by the depth, and the depth is actually 9 inches or 0.25 yards. So we ended up with 3,073.6. And in our quantities for MQ, for the plan view, we had 3,074 or 5. I don't recall, but it checks out. And the same thing here with the HME volume table. We can do the same thing. The asphaltic surface is 60.91 times 2 tons per cubic yard is 121.82. We had these areas and we ended up with 122.75. So again, we're within a tolerance there. And the same goes here for the sidewalk. We're also able to check using those volumes that were computed from the cross sections. So I'll take a little bit of time here to show you some of the advanced versions of what we're working on here. This corridor version 2 file is kind of where we ended up. I'm showing you the example, but what if we want to bring in a different purpose or a different code set style and apply that? I'm going to use the generic corridor that I had used and pull that code set style in for quantities. Let's do that. Drag it in. Now we can apply that. Okay. Take a look at the quantity takeoff manager. And we lost our formulas. That has happened to me in the past, which makes me always check for it to make sure that it is still attached. So I'm going to just reattach that information there. So now we should be able to utilize takeoff We'll just do the summary report again. And there are all those items that we did not create in this particular file, but now that magically there they are. So the rendering should also work because we pulled that in from a file where we had it rendered as 3D. And sure enough, it does. So in all my examples, I was just doing takeoffs utilizing the summary report. But there is also a detailed report, and you can do based on your drawing extents. You can do it by sheet or by selection sets, or you can limit it to certain ranges. You can select a particular pay item and only do one. So I'm going to use, if I select the alignment in the reference file and I do, it always pulls out the alignment information from that file. So it also looks for pay items from that file for some reason. But if you do the corridor 2, which is the file we're in, it then picks it up. So we can go under here and see what we have for areas. There's our square yards and square foot. Detailed counts. There's our tack coats. Different centroid locations. There's different seating areas. There's also specific files created by the DOT for, as you can see, asphalt items, base ag items, beam guard items, and these will actually create a table that matches up with your bid items. It isn't working in this particular example because I did not use the DOT standard bid item table, but this is quite useful for creating miscellaneous quantities tables. You can save it as a template file, or if you select an HTML version, you may actually save it as an HTML. And then you could pull that into spreadsheets. Really very useful tools. Well, I think that's all I have for today. I'm going to make myself available. I believe I heard we have 10 minutes for questions, and I hope you have some, and I hope I'm able to help. There's a lot of information that was covered today. I knew I kind of flew through it, but as I said, I'll be available for questions. So thank you.